Welcome back, everybody. This is part 2 of section 4.2. We've got 2 more quick topics to discuss, and I'll let you out of here. All right, the first is the intermediate value theorem, or we can call that IVT, intermediate value theorem, and the antiderivative. Now, the intermediate value theorem, let's see what it says. It says, let A and B be 2 numbers such that A is less than B. If f is a polynomial function such that f of A and f of B have opposite signs, then there is at least one number C in between A and B. All right. Now, this definition is tailored so we can find maybe a 0 of the function, but we don't have to. We just know that there is a number C in between, right, where f of C does exist. So here is an illustration of what we're saying, right? I have A up here and I have B down here. They have opposite signs, right? F of A and f of B have opposite signs, right? B is positive. As long as my function is continuous, there has to be at least one number where f of C equals 0. All right? So let's try an example. Show that let's try. Show that the function f of x equals negative 2x cubed plus 4x plus 5 has a real 0 between 1 and 2. All right. So the intermediate value theorem says if my function is continuous and I have opposite signs for my y values, right? For my y values, that means I have to pass through 0 at some point, right? I've got a y value that's positive, a y value that's negative. I have to pass through 0 at some point. So the first thing is look at the function. Is it continuous? Now we know that all polynomials are continuous, so that's a yes. So is it continuous? Check. The second thing I want to know is what is f of 1 and what is f of 2? All right. So I'm going to ask you at this point to pause the video and figure out what f of 1 and f of 2 are. All right, so hopefully you took 1 and plugged it into your function and 2 and plugged it into your function. I got 7 for this one and negative 3 over here. So basically what this is saying is that I have a point at 1, 7, and 2, negative 3. I don't know what happens in between, but I do know that it crosses at least once. So you can say by IVT, we know there is at least one real 0. There we go. All right. So let's try one more quick example. So I'm going to give you my function. My function is f of x equals x cubed minus 9x plus 5. And I want to show at least one real 0 between -4 and -3. So somewhere in there, I want to show that somewhere in that interval, there is at least one real zero. Could be more, but if I can prove there's at least one, I'm good. So we start by looking at our function, and we see it's a polynomial once again, and all polynomials are continuous. That is the wonderful thing about polynomials. So now we're going to take a look at what f of negative 4 is and what f of negative 3 is. All right. So pause the video once again. Try f of negative 4, f of negative 3, and let's see what we get. Okay, so hopefully you paused the video. I got negative 23 and positive 5. So by IVT, there is at least one real zero. Yeah, I can do that better. Real zero. All right. So remember, you always have to find continuity first. Right? And we said that was a check. And then we got those two numbers. Now, with this type of problem, this has to be here. You have to invoke the intermediate value theorem, because this by itself tells you nothing. The conclusion is, by the intermediate value theorem, right, it's already been proven that there must be at least one real zero. Otherwise, you got to prove it. So you need to write, so by the intermediate value theorem, I'll take IVT. There is at least one real zero. Okay. Let's go on to the antiderivative. Now, the antiderivative basically means we're going to do the derivative backwards. So let's take a very basic function, y equals x squared plus 3. Let's do the derivative, then let's go backwards, and let's see where we wind up. So in order to do the power rule, I take my exponent, I multiply times my coefficient, right? And that's my new coefficient. So I have y equals 2 times 1 is 2, x, then decrease the exponent by 1. All right. So I do 2 times 1 is 2, x, I decrease my exponent by 1, so it's 2x to the first. Now remember, this is 3x to the 0, so 0 times 3 is 0. Right? So 0 times anything is just 0. So our constant, the derivative is always 0. Now I want to go backwards. So what's the last thing I did? I decreased my exponent by 1. So what's the first thing I want to do to go backwards? All right, the first thing I want to do is I want to increase my exponent by 1. So I have, right? And then after that, I times it by my coefficient. So to go backwards, I want to divide by the coefficient. And that's how you do the power rule backwards. So if I have y equals 2x, right? My exponent is 1. So I want to increase my exponent to 2. Right? So I have y equals, I'm going to increase my exponent to 2. Then I'm going to take my coefficient and I'm going to divide by that new exponent. All right? So that equals just plain old x squared. Now, question for you. did I get back to where I started? I started with x squared plus 3. The answer is no, I didn't quite get back to where I started, but I got really close. All right? So basically what they're saying is that, right, this constant, it's impossible to know without additional information what that constant is. So what we do with the antiderivatives, we just say plus some constant c. Now c could be 0. In that sense, the antiderivative would just be x squared. C could be 1, could be 2, could be 3, could be 4, could be 5. There's a whole family of functions that it could be. Now, in problems that you'll have in this section, there's going to be additional information given to you that will help you find out what C is. All right. If there's not additional information for you, then your antiderivative is done just like this. All right. And when you get into Calc 2, again, when you do a definite integral, that C will be taken care of. But for right now, there needs to be additional information given to you in order to find out what C is. All right. So let's try a function. All right, so I'm gonna had one in mind, but I'm gonna switch it up a little bit. I want to step it up a notch. I've had enough of power rules. So we're gonna find the function whose derivative is sine x, and passes through zero, 2. All right. So this is the additional information we're going to use to find out what C is. But the first thing I want to know is if my derivative is sine x, right, then I want to know what my antiderivative is. All right, so my antiderivative in this case is what function has a derivative of sine x? All right, so if I think about it for a second, I could say, well, cosine x has a derivative of negative sine x. So I can say my function is negative cosine x plus c. All right. Now remember, we don't know what C is at this point. However, what we do know is that when x is 0, y is 2. So I'm going to plug those two values in. So I have 2 equals negative cosine 0 plus c. Now lucky for us, we know our unit circle and we know that the cosine of 0 is indeed 1. So that's 2 equals negative 1 plus c. So I add 1 to both sides, and I get C equals 3. All right? So here's the key. You now need to take this right here and rewrite it as your final answer. All right? So my final answer would be y equals negative cosine x plus 3. And that is the function whose derivative is sine x and passes through 0, 2. All right, so this will also help you with things like if you were given acceleration, you could get velocity or position or something like that. All right, like I said, these are two very quick topics. Glad we could get to them. Won't keep you anymore. There is additional practice on the way. Thanks for listening, and I'll see you all next time.